Question 7 is testing your knowledge of organic reactions. So we're given a flow chart, and the first thing we have to do is work out what goes in that box there between the alkene and the alcohol. So we need to be thinking, well, what can we turn an alkene into that we can then turn into an alcohol? And the answer is halogen or alkane. So ultimately, we need these two OH groups to go onto these two carbons. They're the two carbons in question. So what we need to do is turn this into a halogen or alkane, and then we're going to substitute these halogens for OHs. So the missing compound would be this one here. Reagent A, therefore, is going to be bromine, Br2, because when we add Br2 across this double bond, we're going to end up with bromine atoms on these two carbons. Reaction R, so this is part C, reaction R forms a mixture of two alcohols that are structural isomers of C5H12O. State the reagents and conditions needed for reaction R. So how do you turn an alkene into an alcohol? You react it with steam or H2O gas, and you must have a temperature over 100 degrees C to get the steam, and you need a strong acid catalyst. So I've gone for H3PO4, phosphoric acid. Definition: what's meant by the term structural isomers? Same molecular formula, different structural formula. And then the two structural isomers that are formed in reaction are, so if you think about water, I always think about water as HOH, and when you add across a double bond, the two parts of the molecule that you're adding across, so in this case it was Br2, so BR, Br on there, Br on there. With water, if you think about it as HOH, you can put an H on there and therefore an OH on there, or you can put the H on there, the OH would go on there, and that would give you different structures, hence the isomers. So the answers are down there. So you can see I've written up, think of water as HOH when you add it across that carbon-carbon double bond. And just be careful with your connectivity. So the oxygen must be bonded to the carbon. Don't have your OH group floating in midair. Suggest why 2-methylbutadiene is less soluble in water than either of the structural isomers. Well, we know that the structural isomers are alcohols. So why are alcohols more soluble than alkenes? It's all about hydrogen bonding. So 2-methylbutadiene is an alkene, can't form hydrogen bonds with water, whereas alcohols contain those OH groups, lone pair on the oxygen, and can form a hydrogen bond with the H of water. Nice question here with quite a few marks. Yeah, 6 marks going for it. Describe the oxidation reactions of propan-1-ol using a suitable oxidizing agent. So obviously we're going to need to name that oxidizing agent and indicate how the different reaction conditions can dictate which organic product forms. So they're going to be wanting you to talk about reflux and distillation. Include reagents, observations, and equations in your answer. So we'll start with the distillation. So distillation produces an aldehyde because as this volatile aldehyde product is formed, it's carried away from the oxidizing agent by the distillation apparatus, and so the oxidation only takes place once. The equation is the propan-1-ol plus 1 mole of oxidizing agent makes propanal and water. If you carry out reflux, then you're going to produce the carboxylic acid, which would in this case would be propanoic acid, because as your volatile aldehyde is produced in the first oxidation, it falls back into the reaction vessel, because reflux is the continuous evaporation and condensation of a volatile substance without loss of product. It's going to go back into the reaction vessel and where the oxidizing agent is still there, and so you're going to get both oxidations taking place. And so this time the equation looks like this: propan 1-ol plus 2 moles of oxidizing agent is going to make propanoic acid, but you still only get 1 mole of water. So you only get water produced in the first oxidation reaction. The oxidizing agent is acidified potassium dichromate, and the colour change, the observation, is orange to green.